Hi guys, so in this video we're going to be getting an introduction to probability and frequency. So this is a part of the CIM course and it's not too difficult, so it shouldn't take too long to do. But this is just an exam style question, I'm just going to go through it. I think it'll just be a good introduction because it kind of shows the way that we have to analyze probability, and then we'll go into a bit more detail later on, like such as tree diagrams and stuff like that. So this question over here is 10 marks. This is just the first two parts of it, which are worth 4 marks. So the mass of x grams of each of 100 oranges is found, so results are shown in the table. And we have to calculate the estimate of the mean mass of the oranges. So it's asking us to calculate the estimate, which means there has to be a specific method to calculating it. So we know that mean is an average, and it's basically sum of values over number of values. So in this case, we're told that there are 100 oranges, so that's going to be divided by 100. But then the sum of values, we're not sure of, because the sum of values would be, we multiply the frequency by the mass, but the thing is the mass is a range here. What they want us to identify though is the middle of the range. So an estimate means that it's kind of like generally correct, and the best way we can do this is finding the middle of each range. So we can just assume if it's between 0 and 100 that they're likely to maybe be like 50 grams. So what we can do is do that for each one. So the middle of 0 and 100 is 50. For 100 and 140, it's 120. 140 to 180 is 160. 180 to 250 is 215. 250 to 300 is 275. And then you multiply that by the frequency and add them up. So you get 50 times 4 plus 120 times 14 plus 160 times 22 plus 215 times 35 plus 275 times 25. So this over here is equal to, just put in the calculator, and we get 19800. And we divide that by 100 now, since there are 100 values. Let's go ahead, divide by 10. Divide by 100, divide by 100, which is equal to, well, the zeros cancel out, so we get 198 grams. So this is a good estimate because we're not sure that that on average they're going to be 50 grams. Like for example, what if all the apples in this range were all 99 grams? That's possible, in which case our mean would go up. However, we're not sure because it's a range. They don't tell us where it's more heavily weighted. So we have to just assume it's in the middle. So 198 grams is our answer. Now for the second part, 2 of these oranges are chosen at random. So calculate the probability that they both have a mass of 140 grams or less. So this part here is interesting. Let's start with the first orange picked. So we're assuming that they pick out one orange, then they leave it out, and then they pick out the second one. So they both have a mass of 140 grams or less. So that means they're going to be in these two sections here. So in the first instance, getting one that's 140 grams or less is 18 out of, well, there are 100 values, so 100. 18 out of 100 chance, because there are 18 oranges that have that given mass. Now the second one, so that's for orange 1. For second orange, well, you've taken out one of the oranges. You're going to have to assume that you've taken out the orange with a mass of 140 grams or less. Otherwise, your situation has failed. And you have to also assume that the mass, that orange gets taken away from the total. So what that means is that 18 oranges initially, but then you remove one of those 18 because it's 140 grams or less, and you get 17. And the denominator will be 99 since you've taken out one orange from there. So that's orange 2. Now to combine these, since these probabilities are reliant on each other, we have to multiply them. So 18 over 100 times 17 over 99 is equal to 306 over 9,900. And the reason you multiply them is because they're reliant on each other. If it was or, that one of them or the other has 140 grams or less, then you would add them up. But in this case, because the situation only works if both of them have a mass of 140 grams or less, you have to multiply them. So that gives you 306 out of 99000 answer. You could simplify that further, but it's not really necessary. Let's move on to the next parts of the question. All right, so for part 3, we're going to have to ignore the first 2 rows because it says the oranges with a mass of 140 grams or less are removed. But from the remaining oranges, 2 are chosen at random again, which would calculate the probability that one orange has a mass of 250 grams or less and the other has a mass of more than 250 grams. So the wording of the question actually makes it so that you can pick out the lower, the lighter one afterwards as well. You can pick it up first or last as long as the other one is heavier. So let's start with the first scenario, which is that you pick up the one that's less than 250 grams or equal to it first. So given that we remove the first 2 rows, which are 18 of the 100 oranges, there are 82 oranges left. And of those 82, well, these 2, so we're just going to X this one first. So these 2 are correct, but this last one is wrong. So 22 plus 35 is 57. So 57 of the 82 oranges hold one that is lower than 250 grams or the same. And then you're going to multiply it because it's also dependent on the other one. The other one has to make sure that it is greater than 250 grams in the case that the first one's the lighter one. And in this case, it switches. So this one is bad, and this one's good. However, we have reduced 1 from the 140 to 250 range because that has already been picked out first. So 22 plus 35 is 57, but minus 1 is 56. And then 81 minus 56 is the number of oranges that are heavier than 250 grams, which is 25. So 25 over 81, since there are 81 oranges left, is our first scenario. Now our other scenario is basically the same way but reversed. You pick out the lighter one. Last after the heavier one. However, it doesn't really matter. It's just same thing as the first one because they're getting multiplied out. So the numerator and denominator become the same. So therefore, it's equal to basically 2 of the first one. And now what we can do is just simplify that down. So that becomes 2850 over, and then 81 times 82, 6642, which is equal to, so we can actually simplify that down further. If we divide by 2, we get 2850 divided by 2, 1425 over 6642 divided by 2, which is 3321. So that's the fractional form of it, but it can actually be simplified further by dividing by 3. 1425 divided by 3 is 475. Then 3321 divided by 3 is 1107. So I think this might look like it's the simplest form, but I think what's important to realize is that at CIM level, writing fractions in simplest form isn't necessarily required unless it's explicitly stated. So this over here would be fine, even if it's not simplest form. But if you want to write as a decimal, this would be equal to about 43%. That's as a percentage. As a decimal, it's about 0.429, ... which is about 0.43. So that would be the answer to this question. I'm going to write 0.43. All right, so here are the last 2 parts of the 10-mark question overall. So the first part of that last part says complete the frequency density column in this table. So what does frequency density mean? It just basically means the number of, the frequency divided by the total number of values. In this case, for example, take the first one. It's 4 over, well, there are 100 oranges, so it's 4 over 100. 4 divided by 100 is equal to 0.04, so that would be our frequency density. Then we have 14 for the next one. 14 divided by 100 is equal to 0.14. So next one would be 0.22, 0.35, 0.25. And for the next part, it's draw a histogram to show this information. So it's graphing frequency density over mass in grams. So first thing we want to do is make an appropriate scale size for this frequency density. So this goes up to about 0.4. So we can do it in 0.1. So 0.1, then this one would be 0.2. That's 0.3. We'll put that over here. 0.4. It doesn't really matter how you scale it as long as you scale it correctly. Now, the mass in grams, it's important to make sure that you know how long each bar should be. It should span the length of the range. So for the first one, it's 0 to 100 basically. So the bar should go up till here. Should go like that length. And the frequency density is 0.04. So if you look at the intervals, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intervals between 0.1 and 0, which means each one represents 0.01. So you just go up 4. 1, 2, 3, 4. Okay, that's it over there. Oops, let me just draw that again. That's what the first one would look like. Now, next one's from 100 to 140. So this one's going to be a much thinner one since the range isn't as big. So the distance between 100 and 150 is 1, 2, 3, 4. It's about 10 between. So that means that each one, if 50 is the distance in between and each one represents 10, each one will represent 5 then, each individual line. So we just need to move across 8 spaces then. 1, 2, 3, 4, 5, 6, 7, 8. So that would be over here. And this one has a frequency density of 0.14. So you would go up to 0.1. And then you go up 4 more spaces. 2, 3, 4. 2, 3, 4. Yeah. So that would go up till there. Obviously, your lines would be a bit straighter than mine, but that's generally how it looks. And then finally, the next one would be 140 to 180. So again, find 180. 180 would be about here. Well, no, it would not be there. It would be around 180 would be here. That's where 180 would be. And 180 goes up to 0.22. So you'd go all the way up to 0.2. And then you would add a few. So you'd add 1, 2. Yeah, that's where it goes to. And then you would draw 0.35 for 180 to 250. So 250 is really easy to see. So you just need to draw it up till 0.3 and then go up to 0.35. So 1, 2, 3, 4, 5. That's how you'd go. I'm drawing this very freehand, but you would use a ruler, obviously. And then 250 to 300 is just the remaining portion, and it goes up to 0.25, which is in between 0.2. So go up to 0.2 first, and then go up 5. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5 here. And there you have your completed histogram. So it should look something like this. What the mark scheme's gonna mark you on is if the length of your columns is correct based on the ranges, if you've got an appropriate scale factor going up, and then if you've drawn the bars correctly. So just make sure you do that. So I hope that this is just a good introduction to how probability is meant to work, and let me know if you have any questions about how to approach these kind of questions. Thanks for watching.